Hey everybody, Dr. Baird here. I am going to go ahead and walk you through how to do assignment 1, our first SPSS assignment. This is going to be the assignment in which you do two really basic sets of things. First, you are going to create a rudimentary data set based on the surveys that we have. These are the surveys that you took in our class, but also the socialization class took them, and also education, culture, and society took them. Now, what I'm going to go ahead and do is I'm going to go ahead and walk you through how to input variables for three of these variables that we have here. I'll go ahead and show you how to do it for a nominal variable, an ordinal variable, and one continuous variable that I believe is a ratio variable. So I'll go ahead and do that, and I'm gonna speed up the process once we get to actually inputting the rest of the variables and putting in the actual data observations, because unfortunately, I'll go ahead and tell you right off the bat, this is going to be the most tedious thing that you do in this class. We'll do other stuff with state, obviously, but none of it's going to be involving entering a decent sized set of data like this. So it's going to take a little bit of time. It's going to be something that you're going to have to make sure that you are doing accurately, but it's relatively simple. So let's start off, and we're going to name all the variables. As you can see in the instructions here, you're going to use a naming convention that is just Q1, Q2, Q3, Q4, all the way up through Q7, or sorry, Q8, for all the 8 questions that are in the data set. So start with Q1, Q2, Q3, Q4, Q5, Q6, 7, and Q8. Okay, so now you've officially created 8 variables. Now, they're not exactly correct in terms of what we need, but we'll get there. So the first variable that we have is a nominal variable that has 3 categories that are possible. This is for gender identification. So for the variable label, just put gender identification. And then there are 3 separate values for this. Now, we'll go ahead and make the first one male, put male as your value label. The second one, female for the value label. And then the third is other non-binary. And that's basically it. So you've created that first variable. And now you're going to select the measure. One of the things you'll see here is SPSS uses a different term than what we use. We generally say continuous variables, which means both interval and ratio. Here it says scale. There is also ordinal and there is nominal. This, since there is no hierarchy to our categories, is a nominal variable. So there you go. You have effectively created your first variable in SPSS. Now let's move on to, let's do a continuous variable. So we're going to move on to Q3, which is going to be our income variable. So let's label that family income as it is. And then for the measure, let's go and get that done right off the bat. Let's go to scale. Okay, I think I accidentally set Q4 to scale, which actually it is a scale variable as well, so we'll go ahead and leave that as is. So for the values, you really don't have to input anything because the value is going to be whatever you manually input into the data cell. It can be anything because it's a continuous variable. So in theory, your lower boundary is an answer of 0. In theory, your upper boundary is, I don't know, let's say one of the CNU students in my class's dad's Jeff Bezos, so it's like multiple billions of dollars. So since there's not really a range of values that you need to specify, you can just leave that blank. And so there you go. That's your that is your income variable. Now let's go to a variable that is ordinal. And so Q6 is the likelihood in which somebody votes. So let's say that this has a label of voting likelihood, which I think I misspelled. I am not an English professor. I am indeed a sociologist. So, oh, look, yeah, of course I misspelled it. Okay, likelihood. There we go. Okay, so this is going to have variables that we need to define. So the values are going to need to be ordered in a way that makes sense. And to a certain extent, what makes sense is going to be up to the discretion of you as the researcher. I'm going to go ahead and label it so that the lower values indicate that it is less likely that somebody votes. So we'll go ahead and say the 1 value is definitely will not vote. There you go. 2 is somewhat more likely to vote, but still not very likely. Unlikely to vote is 2. 3 is going to be somewhat likely to vote. Somewhat likely to vote. And then 4 is somebody who definitely will vote. That's it. You have your ordinal variable. Now, what I say when it's kind of like up to the discretion of the researcher, what actually makes sense, is you could obviously flip that. You could make the 1 value to be definitely will vote, and the 4 value will be definitely will not vote. It's what makes sense to you in your head. Ultimately, you're going to be the one that's interpreting this. And so as long as it makes sense to you in your head and you're able to interpret it when you actually run the analysis, that is what is important. And so if I were to be running this analysis, I would just remember that I coded it so the lower the value, the less likely it is that somebody ends up voting. Now, there is one other potential value that comes from the Q6 question, and that is will be ineligible to vote due to age or other reasons. And so this actually is going to segue into how we handle missing variables. Generally speaking, missing variables are variables in which there's not a valid response in the survey. In this instance, will be ineligible to vote for age or another reason. I mean, that just basically means that they're taken out of the sample in terms of a valid response. And so you need to have some sort of value that signifies that they are missing. In this case, I'm going to go ahead and do -9 as the missing value. -9 is something that's really common in data sets, especially data sets that have already been done by the government. They tend to code their missing values -9. That's generally because -9 is not typically a value that would come up most frequently. Only in interval variables would a negative number even be something that is possible. For this ordinal variable, like, there's no real reason to code it with a negative number. With ratio variables, you can't go below the fixed 0 point anyways. And so -9 is kind of a good number to use for your missing values. It's some people's knee-jerk instinct to use 0 as a missing value signifier, But the problem is that, I mean, there could be instances in which 0 is a valid response. Like, for instance, on Q3, it could be the case that somebody gives $0 for their annual family income. I mean, maybe it's the case that their family is on some sort of assistance program and they don't necessarily have, like, income from a job, and their response is $0. And you have to be able to input that 0 somehow. And so if it's already taken for missing values, then you're not going to be able to. So we'll go ahead and go with -9, because -9 generally isn't going to be a value that we're going to use. In fact, we'll go ahead and go with -9 for all the missing values in all the variables, because there's probably going to be at least one missing case in any given one of these variables. I was just going through the surveys, and yeah, there are a fair bit of instances in which students, for one reason or another, did not enter a response into the question, which is fine. I kind of expected that. In fact, I was hoping that there would be a handful that didn't, because y'all have to learn how to deal with missing values. Missing values are a reality of survey research. People don't always enter a valid response every time. Or sometimes they enter a response that's just garbledy-gook, and you don't really know what they're trying to tell you, in which case it's best just to write it off as missing, as opposed to trying to interpret whatever sort of bizarre scribbling they put there. So, all that said, I am going to go ahead and unplug my microphone, and I'm going to go ahead and make the rest of these variables. I'll speed up the process of this with, the magic of iMovie. And I will come back on the other side once all the variables are created, and we can talk about how to start inputting values. Hey everybody, so now that we have our variables created, I did forget to include one very important variable that's going to be our last. This is going to be the case ID variable. We'll just call it ID. It is a scale variable, and now this is a variable that you're not actually going to use in any of your analysis. Rather, this is a variable that is just going to give you a point of reference for every case. Now, one of the things that you'll notice on the surveys is I put in the upper right hand corner a number, and this is just going to be your case ID number. This links a variable back to every individual respondent, and this is going to allow keeping track of individual cases a lot easier. So let's say that there's one case that's an outlier or has something specific that you want to reference, then you're going to have a number for it. So go ahead and make your case ID variable, and then it's probably best to put it at the beginning. So you can just drag any given variable to the top, and there, now it's in the right order. I think that should be it for the variables. Now, the default view in SPSS is the variable view. So that's where you're going to start off. Naturally, if you are making a data set, then you are going to want to start there, because that's where you're going to start with your variables. But once you have your variables all set up and you're ready to actually enter data, you're going to go to data view. And now data view has all the cells right there for you, and every column is going to be a new variable. And so you have your case ID as number one because we pulled that to the top. Then you've got Q1, Q2, Q3, Q4, Q5, Q6, Q7, and Q8. And if you mouse over, it shows you the variable label. So you can see Q1 is the variable name, but mouse over it, and there's gender identification. Same thing for Q5. Mouse over, did you vote in 2018? Now we are just going to start the laborious work of entering all the data. Now I numbered all of the surveys, and there's a total of 66 cases here. All of them have their case ID in the upper right hand corner, and when I scan them to put them in PDF form for y'all to look at, they'll be in order, which should be helpful. So it's probably best to just go ahead and enter them in order. I'll do the first couple here, and then I'm going to speed things back up again because this is going to take a little bit for both you and I. So naturally, let's start with case 1. So survey 1, case ID 1. Q1 is going to be female. So go to variable view, confirm how you coded it, and we coded male 1, female 2, and I believe other 3. So that's going to be a 2. Q2 is sociology major or other. This is a simple binary variable. Sociology major is 1, other is 2. Case 1 is another major. Estimated yearly family income in dollars. This is a continuous variable, so it's not coded a specific way. Case 1, estimated income, $95,000. Now, you'll note that SPSS defaults to having 2 decimal places. You can change that in your variable view by number of decimals right here. I just left it as the default because it doesn't really matter. But in theory, I guess if somebody was so specific that they wanted to include the number of cents their parents make, you could make this $95,000 and 73 cents if you really wanted to. But nobody is that detail-oriented that they entered that in their survey. Q4 is estimated CNU GPA. This case had a 3.3. Q5, did you vote in the midterm election? Did vote eligible, but did not, or ineligible? I can't remember how I originally coded that, so let's go back. Did you vote? 1 did vote, 2 did not vote, and then 3 ineligible to vote. We're just going to count as a missing case, which if you remember, we coded all missing -9. So this person was eligible but did not vote, so that's a 2 coding. Q6, how likely are you to vote in the 2020 election? That's our ordinal. With definitely will vote coded 1, and unlikely to vote, definitely will not vote is coded 1, unlikely to vote coded 2. So the higher the value you enter, the more likely they are to vote. So it is the case that this person is somewhat likely to vote. And so that is going to be a 3. Q7, how many hours a day do you spend on social media? That is in hours. So it's just standard continuous. This person entered 2. So 2 hours. This is where having the decimal places is going to be handy because there are some people that did numbers after the decimal. So there, for instance, on case number 23, they entered 5 or 6, and so I actually wrote average value 5.5. I did that for anything in which there was an ambiguous number. I just averaged it out. Case 31 has 3.5. So case 1, 2 hours. Lastly, what social media platform do you use the most? Now, case 1 actually marked 2 things. I kind of arbitrarily chose one. This person picked Facebook and Instagram. I marked out Instagram and put in Facebook. That's my fault. That's a product of bad survey design. That's why you want to make sure that your surveys are really, really well considered if you get into writing survey design. And so I didn't put explicitly select one. Most people inferred select one, but apparently this person did not, and actually a handful of others did not. In which case I just marked off one and left only one option. Kind of arbitrarily. It does harm the validity of our data. That's what it is. But it does teach a vital lesson that you should take great care in how you word questions. So this person actually put Facebook and Instagram. I crossed out Instagram. And so Facebook is coded 2. So this person is going to be coded 2. So there, that is your first case. We'll do one more, and then I will speed this up and stop talking because everything is going to be fairly repetitive from this point forward. Case 2, also female. So 2 coding for Q1. This person is a sociology major, so 1 coding. This person estimated their family income at $65,000, so go ahead and put it in that continuous. Q4, estimated GPA, 3.77. This person seems to know their exact GPA. That doesn't seem like much of an estimation. Q5, did you vote in the midterm? I believe that's coded that if they did vote, that's a 1. And so this person did vote in the midterm election. Good for their civic engagement. How likely are you to vote in the 2020 election? They said they definitely will vote. So that is the highest coding. That's 4 for our ordinal variable. And then how many hours a day do you use social media? 3.7. That's really, really specific, but that seems to be what they put. So 3.7. And then their most frequent media platform, social media platform, is Twitter. I remember from just looking at it, Twitter's coded 1. And that's it. That's the second one. So just do everything like this. Couple of notes on the surveys. I did, in cases where people gave more than one answer for a continuous variable, I just wrote the average. So you should just do the average. Once again, kind of harms the validity a little bit, but it'd be easier for you to manage. So just input what I wrote. So for instance, on case number 5, how many hours per day do you use social media? Somebody put 2 or 3. I just put 2.5 average, and that's what you'll input. There are a fair amount of missing cases, especially when it comes to that Q3 variable for how much family income would you estimate your family pulls down. And there's a lot of missing on that. So that, unfortunately, does harm validity and reliability. But what are you going to do? You can't force people to enter answers. So in those cases, do enter -9, which is what we coded our missing variables. Or whatever you chose to code your missing variables. I mean, you could stray and do something other than -9, but -9 is what I used for the reasons why, I said generally -9 is a value that you're not going to use in normal circumstances. And it's kind of the convention in big data sets. So typically missing data is coded -9, but other people have other conventions. I will say in Stata, missing values actually don't have a number value code them. They're universally coded period. Which is nice because you never ever use period in a data set normally, and so whenever a case is coded period, it automatically gets recognized as missing in a Stata data set. But I could sit here and espouse the virtues of Stata all day. SPSS is what we're working with in SOCL 340. So, best of luck. I'm going to go ahead and start coding all 66 of these. And I'll see you on the other side when we actually start data analysis.
Postcards from the pink bath, paint leisure as a cloaked horse through a stained glass St. Peter. Hack faith healer, cheat death to the very end. Cherry wood and nickels on his specs for the ferryman. XO, Zodiac, a pentagram expo. Pet cemetery and electric fresco. Abaddon, threshold, flash forged in a galley. With undead orcs pulling ores through the algae. Smash cut to a smoke bomb's quarantine guards like all signs correlate with sorcery. More dormant cerebella is awoken by the smell of sordid power and defecting shortly after. Fist bump, dry land brackish. Catnap 15 back to Swiss cheese, the flagship. Blue in the menacing grip of a day for which you're manifestly unfit. Not to be as right, next question. A build winged shoes or autophagy. Silk screen band tees, take a part of VCR. Ringer off, canned peas, cabin fever, me or more. Patently adhering to the chandelier key and door. To usher in the understated anarchy of leisure force. Let a purple tongue erratic caballeros up over the black rainbow into the house of mirrors. To become 1,000 zeros, echoing a twisted alchemy. Freak flags flutter in a circadian free jazz. Sleep apnea, scratch and bring that beat back.
Okay, welcome back everybody. So, the data set is done. That took a bit, but it's done. So now we're going to move on to actual analysis. Since that data set that I just made is going to be the data set that you are going to end up using for your assignment, I am going to use a different data set so you can come up with the numbers on your own in terms of the correct answers, or at least the correct statistics for the given variables that you're going to be analyzing. So what I have here is actually the GSS 2018. We'll be working with this a little bit later on in class, but the GSS comes out on a yearly basis and is the most thorough and complete data set that is publicly available. It is amazing what kind of variables are in here and how many cases they have. So, that said, you'll have an opportunity to pour through the GSS a little bit later on in the semester, but I'm going to use it right now to show you how to do the basic kind of analysis that you're going to need to do for assignment 1. So, let's start off with this first bit. For the variables in which are appropriate, run frequency distributions in one relevant table. Alright, so I shouldn't have to tell you that for the variables in which it is appropriate to do a frequency distribution is going to be categorical variables. Let's just choose a random one. We've got literally thousands. So how hard is it to take time off work for an individual? So to run the frequency distribution, I got a little ahead of myself. Go to Analyze, Descriptive Statistics, which is where you're going to do the majority of your work for this assignment, and then go to Frequencies. Boom. Now, this little symbol with the 3 circles meant to signify categories equals a categorical variable. This, the little ruler, is a scale variable, which is how SPSS says continuous. So let's use a categorical variable because that's what would be appropriate. I lost the variable I was originally looking at. Let's see. Ballot used for interview. Science research is strongly in favor of harmful results. Science research is strongly in favor of benefits. Which language R speaks most fluently? Science knowledge. The universe began with a big bang. Okay, this seems interesting. This seems like a categorical variable for people people's opinions on the Big Bang. We're going to run this with one relevant chart. Actually, I've got table in there, but I'm going to fix that before I get you the assignment. But I want a chart. Now, for a categorical variable, naturally bar charts work great. Pie charts work out really well, and histograms. I am going to assume that this is a good categorical variable in that the options are mutually exclusive and exhaustive. And so that being the case, it should work out best in a bar chart. So let's do that. That sounds good. We're going to run this variable on people's belief in the Big Bang. We're going to get the frequencies, and we're going to get, looks like a, actually, no, scratch that, pie chart. We're going to run a pie chart. If this is a good exhaustive variable, then a pie chart should work out really, really well. Statistics, well, really none of these statistics work for our categorical variables, so we're going to go and leave all this out. Like mean, median, and mode, all best for continuous stuff. Skewedness, kurtosis, I mean, you know what skewedness is. Kurtosis is kind of similar. Maybe you'll learn about it in grad school. But all this is best for for continuous stuff. So since we have a categorical variable, let's just run it as is. Let's see what comes up. All right, cool. Here we go. Wow. I guess I didn't really expect these results. Looks like just a slim majority believe that the universe began with the Big Bang, or a huge explosion. So it seems like the Big Bang theory is relatively divisive. Here's the frequencies. It looks like about 153, not about, exactly 153 said true, about 146 said false. There's a lot of people who didn't know about 103, and 2 just left the question blank. This is inapplicable IAP. We'll get to that later. That'll be handled as missing data when we actually start playing with the GSS dataset. But yeah, so that's it. Like, that's all you're gonna have to be doing for this bit. Be making a chart instead of a table. The variables where appropriate is just going to be any variable that is categorical. I'm probably going to tell you this in class, and I may have it in the lecture slide, but treat your ordinals like categorical variables at this point. Naturally, ordinals can technically be treated as continuous in some circumstances, but for a basic intro to stats course, treat your ordinals as though they're categorical. And so do this for the ordinal variable that is in your survey. So what's part 2? For the variables in which appropriate, run descriptive statistics that provide the mean as a measure of central tendency and standard deviation as a measure of dispersion. Also provide a histogram. Histogram being the kind of chart that would be most appropriate for a continuous variable. All right. This should be fairly straightforward. We're going to go back to descriptive statistics, but instead of hitting frequencies this time, we're going to hit up descriptives. Got to find one of those scale variables, aka continuous variables. Percent of company stock respondent bought with their own money. That's not very interesting. Partners industry code. Oh, that's not a true continuous variable for reasons I guess I could get into. R's height. All right, this one's going to be interesting. We can do R's height. So this is the respondent's height. Okay, cool. So we have R's height. R is how tall. Looks like the variable name is height. And the description is R is how tall. All right, cool. Well, let's go to options now. The 2 things that the assignment asked for is the mean and the standard deviation. That's already there. The four things that are defaulted are mean, standard deviation, min, and max. So you really don't have to click anything. Just leave it at the default. Min and max leave. Why not? It's interesting. So, all right, cool. So let's run these descriptives. All right. So looks like the mean is 67 inches, just over 67 inches. So 67 inches. 67. All right, so yeah, about 5.5 feet. That makes sense. The average in this data is like 5'6", which sounds about right. I think the average woman is about 5'4" ish. I think the average man is like 5'10" ish. So yeah, that's right. Maybe they have a little bit of an oversample of men, or maybe they just have unusually tall women. But yeah, so that's about 5.5 feet. So 67 inches is the mean in the data set. The maximum is 81 inches. So 81 divided by 12. All right, so the maximum, they've got somebody who's pushing up towards 7 foot. Probably gives you a relative idea of how unusual NBA players are. That the maximum height found in the GSS dataset, which I think is like 30,000, or what in this case, actually, okay, 1,400 people answered this question. So the maximum of just under 7 foot, looks like they're like 6'9", 6'10" ish off the top of my head. That is the most out of all 1,400 people to answer this question. So given the average NBA center is about 6'10", 6'11", that gives you an idea of how extraordinary those people are. I think the average height in the NBA is about 6'6", which is certainly a standard deviation or two above the mean from this data set. So cool, we have that. What we need now is the histogram. So the histogram's kind of placed weirdly. So you're going to go to graphs. You can't just tack it onto the initial descriptive statistics the way you can tack a chart onto the initial frequency table. So you're going to go to graph legacy dialog and then histogram. Boom. Okay, so now we got to find our variable again. I can tell you that given the GSS is so big and there are so many variables, it can be kind of difficult to track down your variable. So actually what we're going to do is, since we know the variable name is height, you can right click and then go to display variable names. And now they're actually in alphabetical order, and I'll just type height. Boom. Just put that in a variable. Right now we're not doing any inferential just statistics, so you don't need to worry about putting any more than one variable in. We just want a histogram for the one variable. So just slap that in variable and you're good to go. Here comes the histograph. Boom. There's your histograph. Off the bat, it looks like you got some outliers that are on the very high end and the very low end. It looks like the mode appears to be slightly below the mean. Your most substantial outliers on the low end with a very short individual. Just from my glancing, I'm gonna say probably it's the case that there's more outliers on the high end than the low end. It's just the low end has the biggest outlier. So I'm gonna say that probably the mean is probably larger than the median or the mode, just because there's so many outliers that kind of go towards like 75, 80 inches. But yeah, I mean, we can look at that in more detail using SPSS. That I'll show you another time. But right now, let's stick to the assignment. So cool. So we're 2/3 of the way through the actual analysis part of the assignment. So the last thing you're going to do is you are going to compare means. And this is kind of fun because this is the part where you can, start to do a little bit of inferential statistics. You can start comparing how things affect one another. So this part of the assignment is starting like baby steps towards inferential statistics. So that said, let's get to it. So analyze, compare means. Really simple. Go to means. And right below that, you see what we'll be doing very soon. One sample t-test and independent sample t-tests. Those are going to be, I believe, the first big introduction to inferential statistics we will have. But for now, let's just compare the means. All right, so if you're going to compare means, what you want to do is you want to compare the means on a continuous variable within the categories of a nominal or ordinal variable or a categorical variable. So you are going to want your categorical variable to be your independent and your dependent to be that continuous variable. So actually, I just stumbled on this. R is age when first child born. This seems interesting. So we're going to throw that in there. That's going to be our dependent. So let's look for a categorical. Clergy shouldn't influence voters. So I guess that's that's kind of related to politics and the views on the separation of church and state. Let's give it a go. So I am going to go and hypothesize for a second before we even do it, because I want to kind of give you an idea of what hypothesizing is like, because we're going to be doing it soon. So a hypothesis is an educated guess that can be testable about what you're going to see in data. And so it always should be based on some sort of theory you have or some sort of logical reason behind it. So I know, as somebody who is both a sociologist and a politics nerd, that it is the case that people who live in rural areas have a tendency to be more religious. They have a tendency to attend church more frequently, and they have a tendency on self-report surveys to identify themselves as religious. So I am going to make a logical jump and assume that they have more faith in clergy, and they don't want to limit clergy. So that seems pretty reasonable. Now, also at the same time, I know that in the United States and in most other parts of the world, people who live in rural areas do tend to have children younger. So, my hypothesis is that people who think it's okay for a clergy member, like a priest or a rabbi, just some religious figure, the people who think that that is okay, or to use a religious term, kosher, I'm going to say that they tend to have their children younger. So let's go to options. Well, I'm really only concerned with mean here. So mean, number of cases, standard deviation, like, yeah, that's good. Mean is all I need, but like number of cases, standard deviation's gonna be good too. So let's do it. Let's test the hypothesis. The moment of truth, people. Let's see. All right. Oh, okay. So this is a Likert scale. So this is actually an ordinal variable. So clergy should not try and influence voters. Those who strongly agree with this statement have an average age at first childbirth of about 24 years old. Those who strongly disagree with the statement, in other words, they think that clergy should, or it's okay if they influence voters, they do have a younger age of first childbirth. Now this is ordinal, so like as you move towards strongly agree, that you would assume that the age would go up, but it kind of doesn't. The maximum age is people who are indifferent on the question. The strongly disagree is just over a year younger than the strongly agree. So I don't want to say my hypothesis is like totally supported, because in social science we don't talk in cut and dry terms like that, especially when the evidence is tepid like this, which this is like, tepid. I would say my hypothesis is somewhat supported or lightly supported. It's not a home run, but it's a little bit of evidence that that the hypothesis may be correct. You would probably want to run other kinds of tests or test the hypothesis in other ways before you would definitely say like that's 100% accurate. So yeah, that's the assignment. That's how you're gonna go about doing it. I'll see everybody tomorrow. And best of luck. Naturally, if you have any questions, hit me up in my office hours. That's what the office hours are for. This video is intended to be helpful to you in a guide, but it's not a replacement for office time. So don't be afraid to drop on into Looter 144B, and I'll see everybody